Hi, today we're going to be building a sound timbre that starts out as a sawtooth wave, transitions transiently to a simple sine wave, and then transitions transiently to a square wave, all in one attack, decay, sustain, release loudness contour. This is my own MATLAB and Excel program I wrote for additive synthesis. The first thing we want to do is define a sampling frequency. We will sample at 44,100 samples per second, which is a standard high quality. We want our keyboard to fundamentally build at 300 cycles per second. And this is solely a harmonic effect. We will leave chord, noise, low and high amplitude and frequency modulation, chorus, and random perturbations. We will leave all of those blank. What we're going to do is we're going to set the first 5 harmonics, the first 5 frequency energy levels, to the first 5 transient envelope calls down here. So 1, 2, 3, 4, 5 will end up being linked to 1, 2, 3, 4, 5, but I have not built it yet. Now that I have my parametric chart built, I can save it and move on to our envelope call space. The first thing I'm going to do is build the attack, decay, sustain, release loudness contour. I'm building it as a square window frame, meaning it very quickly rises to a max amplitude, it stays that same amplitude for its entire time, and then drops out suddenly at the end. All of the harmonics are going to fit within that loudness contour. Now it's time to build the sawtooth wave. The way a sawtooth wave works is the harmonics are proportionally laid out like this. The first one, if we set arbitrarily to 100, the second one will need to be 50, the third one will need to be 40, the next one will need to be 35, and the final harmonic will need to be 30. If we were to build that steady state, it would create a sawtooth wave that floods this entire attack, decay, sustain, release loudness contour. However, we want to transition that to a simple sine wave. So we will let 1 unit of time pass, and I say unit because it's normalized, and we will set that first harmonic to remain at 100. However, we will let the other ones diminish to 0, and what that will do is allow that sawtooth wave to transition transiently to a simple sine wave. Cool, but now we want to transition to a square wave. So we're going to let another unit of time pass, and then we are going to transition to a square wave. The way the proportions for a square wave frequency distribution works out is the even harmonics are null, are 0, but the odd harmonics are going to be laid out like this. The first one is 100, remain the same. The third one, we're going to rise it back up to around 50. And the fifth one, we're going to rise up to around 30. And that will create a square wave. So now we have sawtooth wave to sine wave to square wave. We're going to save that Excel spreadsheet, make sure everything is correct, and now we're going to build that sound. Now we'll play it on the keyboard. Let me zoom in to the time domain. First I'll zoom into the first part, and we should see that it looks a lot like a sawtooth wave. Yep. Now we will zoom into the middle of the time zone, and we will see that it looks a lot like a sine wave. Yep. Now we will zoom into the end of the time frame, and we will see that it looks a lot like a square wave. If we were to add more harmonics, those waveforms would get closer and closer to what they are supposed to be. Thank you for watching.